Alright, new day, new estimate code. To be very honest, I was very tired this morning, so I didn't do anything. So let's do it with a bit of a delay. But better late than never, day 16. The sensors have led you to the origin of the distress signal, yet another handheld device. Oh no, the device is surrounded by elephants. They must have gotten lost in these tunnels, and one of the elephants apparently figured out how to turn on the distress signal. The ground rumbles again. So we are in a volcano. You need to get the elephants out of here quickly. Your device estimates that you have 30 minutes before the volcano erupts, so you don't have time to go back the way you came in. Scan the cave for other options. Discover a network of pipes and pressure release valves. Aren't sure how such a system got into a volcano, but you don't have time to complain. Each valve's flow rate in pressure per minute. The tunnels you would use to move between the valves. Even a valve in a room, you and the elephants are currently standing in labeled AA. So it takes 1 minute to open a valve and 1 minute to follow any tunnel from one valve to another. What's the most pressure you could release? Okay, so I have a list with valves. Valve AA has flow rate 0. Tunnels leads to these two valves. So I basically have a graph of valves. What's the most pressure you could release? You're standing in AA. This one has flow rate 0. Tunnels leads to two valves, DD and II. Oh, and I have exactly 30 minutes. Okay. So what I could do is go from AA to DD. That will cost me 1 minute, and I open it, and I got 20. Then I can go to CC, and I open it, and I have a flow rate of 2. So this cost me 1 minute, cost me another minute, cost me another minute. Okay, all of the valves begin closed. You start at valve AA, but it must be damaged or jammed. Its flow rate is 0. There's no point in opening it. You could spend 1 minute moving to valve BB and a minute opening it. Doing so would release the pressure during the remaining 28 minutes at a flow rate of 13. 28 times 13. That's pretty good. Spend your third minute moving to valve CC and your fourth minute opening it, providing an additional 26 minutes of eventual pressure release at a flow rate of 2 or 52. Yeah, 52 is 26 times 2. Total pressure released by valve CC. Making your way through the tunnel like this, you could probably open many or all of the valves by the time 30 minutes have elapsed. You need to release as much pressure as possible, so you need to be methodical. Consider this approach. You move to valve DD. You open valve DD. Okay. This approach lets you release the most pressure possible in 30 minutes. With this valve layout, 1651. Work out the pressure to release the most pressure in 30 minutes. What is the most pressure you can release? And here we have the input for day number 16.txt. There we go. Let's copy my basic script again. And let's take the example input, because that makes everything easier. Let's see. Let me first make sure I can extract the information I want, and then I start thinking about how to represent the situation. And let me turn CoPilot back on. So we extract the flow rate. Yeah, perfect. So we can let me quickly print that. I'm assuming we don't have negative numbers today, so that's not an issue. Then we have line.split, just based on space. Then the valve name is split 1, I believe. There's a certain flow rate. Let me print the length of split. And let's also line.strip, so we are sure that we're not accidentally getting the wrong things. So then we've got the neighbors, right? I guess we should remove the commas. Yeah. Is line.replace the comma with nothing. Perfect. And then split looks like this, right? Yeah. So neighbors is split from 9 to the rest. Let me see. Okay, so we got DD, II, BB, CC, AA, DD, BB until II. That is all perfect. Let's add least do the following. I have not really thought about what my approach is, but at least I need let's go next. Let's say neighbors is a default ticked with lists for n in next neighbor valve name.append n, and then we got this nice list with neighbors. From AA you can go to DD, II, and BB. From BB you can go to CC and AA. From CC you can go to DD and BB. Okay. Now that we have this parsed, we should also have flow. Oh, we should also have like flow rates. Is a dictionary, and then we can say, yeah, extract the neighbor sounds good. Flow rate of valve name is flow rate. I think this code is a bit ugly because the order is not very nice, but who are we to complain? Int object does not support item assignment. Flow rates. let's do that. Yeah, integer objects indeed do not support item assignment flow rates. Perfect. Okay, and now the question is, what are we going to do? So essentially, it seems to be a tree search, because you start at AA. Let me actually draw this out. So essentially, at least for part 1, it seems to be tree search where you start at AA. You can, I guess, have the following actions open and walk, and then for walk you can end up in either DD or II or BB. Those seem to be the options. Then at least for opening, you should only do it if not open already. And for the walking, yeah, you can always do that. Why not? The only thing I am a bit concerned about is that, so the first thing I'm thinking is we can just simply do a breadth first search and then do all these actions. Maybe you can say if not open already, or flow rate is larger than 0. I guess this is an and the flow rate has to be larger than 0. The only thing I am concerned about is this 30 minutes. So let's see. At the worst case, we have 1, 2, 3, 4, 5 actions. 1, 2, 3, 4, 5, 6 actions. So it would be 6 times 6, so it's 6 to the power 30, and that is a crazy high number. Let's take a look. What I'm wondering is if we, so here look, we can go back to the same valves. That's the issue here, right? Because you can revisit the same state. I think what is open and not is relatively small, so it's not that it will take a lot of memory. It's that we cannot very simply get rid of states. You move to valve DD, you open valve DD. What I guess we could do is just be very greedy and always extract all the states, but then in a greedy way only look at the most promising ones. But then the question is, if we do that, will we run into trouble? So the issue is, of course, delayed reward, right? That if we, for example, start by quickly moving to a random place, I don't know, like it is possible that there is some loop which has a very delayed reward, and then we, of course, are going to miss it. So then the only question is, how big is the stack of still using 10 gigabytes of RAM from yesterday, I guess. Or not. Let's go that. Yeah, the question is, how big does our kind of, how do you call that? Like the frontier have to be. So I guess we could do depth first search. We have a certain start. Go away. So we got like our frontier. Yeah, and that is not only start, but I guess because we are, let's see, do we want to have, for example, the, let's actually do the depth. Current flow rate node. And then you also need to know what is open. So open valves is list. Let's already get into the habit of doing this. Because we don't want any mutable things. Can we have an empty tuple? What happens then? Oh yeah, then you just get an empty tuple. Cool. Current flow rate, node, current node, open valves. I guess while frontier sounds good. Depth, current flow rate, current node, open valves, frontier.pop. Let me go away with this. I guess if depth is 30, print, I don't know. Found answer. I guess the current flow rate should be the, just take some notes. Notes, current flow rate should be the flow rate, should be the total flow achieved at the end of 30 minutes. Okay, so then we have action 1, open a valve, and action 2, move to a different valve. So the if the current node not in open valves and flow rate current node is larger than 0, then the new flow rate is current flow rate plus flow rate. Okay, let's say also max depth is 30. Time remaining is max depth minus depth. And then the new flow rate is current flow rate plus flow rate current node time remaining. Oh, I didn't know you could do that with tuples. That's pretty cool. Learning new Python things every day. The new flow rate is that. The new open valves is open valves plus current nodes. And then the frontier we append depth plus 1, new flow rate. I know that I'm going to optimize the frontier in a bit. Did a new flow rate, the current node, we're still at the same place. New open valves. Okay. And then we have action number 2, move to a different valve. For every neighbor. Doesn't matter if they're already open or not, because we can just walk past them. That is always possible. The depth plus 1, current flow rate stays the same. We go to the new neighbor, and the open valves stay the same. Print len frontier. And then let's print frontier 0 to see what's happening. Okay, interrupted already. Okay, so we can move to DD. What? What is neighbors of AA, DD, II, and BB? Why do we suddenly have only DD? Only DD. Only DD. What? Pop 0, maybe, I guess. Yeah, there we go. Okay. So we have DD, II, and BB. We can open DD, and then we have flow rate of DD, and then DD is open. Or we can move from DD to CC and AA, CC and AA and EE. Perfect. Okay. So we have our search now, but it's slow. It will, first of all, it will be slow. Import heap queue. Does that work? Perfect. I think you've got this heap queue.heapify thing. So I want to expand. So what I want to do is every time we go to a new place or like to a new like depth, I want to remove all the non-promising things, right? Because in some of the expansions, we start moving around, never opening any valve. Like at some point, yeah, that's not okay anymore. Although I wonder. Wait. So first of all, we can have duplicate states. Can we have duplicate states? Maybe you can walk to one place, walk back. Okay, let's. Okay, so to do, can or should we remove duplicates from frontier? And then to do sort by most promising and only keep top I don't know. Start with 1000. What I also know is that so that if frontier 0 is larger than current depth, new depth of current depth, and then we can do frontier.sort, and this will sort it perfectly because everything will be one depth, and until max explore. Okay, this is weird. Okay, no, never mind. Perfect. Answer 0. Yes. What the heck? It is not good. Well. Of course, we want to sort by the most promising ones instead of the least promising ones. 1651. Huh, I found a better answer than Advent of Code has. It's probably not good. Let's see. Minute 1, no valves are open. Minute 30, BB, CC, DD, EE. B, C, D, E, H, and J. B, C, D, E, H, and J are open, releasing 81 pressure. Okay. The one thing which is weird is that this pressure is wrong. What I can just do is, so I don't really like the fact that they calculate the pressure per second here instead of calculating the total pressure released over time. Three, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so at the end, all the pressure valves are open. So I think the total flow rate I calculate here must be wrong. Yeah, because here at the end nothing interesting happens. Like he's just standing still and not moving around, which is fine. Fine with me. You rescued all the elephants. I guess it's -1. 1651. Perfect. And then with full confidence we start the actual program and fill this in. I'm 1 gold closer to the answer. And now I'm worried that even with optimal approach, the pressure release won't be enough. What if you got one of the elephants to help you? It would take you 4 minutes to teach an elephant how to open the right valves in the right order, leaving you with only 26 minutes to actually execute your plan. Would having 2 of you working together be better, even if it means having less time? Assume that you teach the elephant before opening any valves yourself, giving you both the same full 26 minutes. You could teach the elephant to help you as follows. Is the question, with the elephant helping after 26 minutes, the best you could do with you and the elephant working together for 26 minutes? What is the best pressure you can release? Man, I love teaching elephants. That would be pretty cool. Teaching some elephants. So you move to valve 2, the elephant moves to valve DD. Part 1. Depth first search part 1. Then let's copy that because that is working. Part 2. I don't think I ever implemented a multi-actor search. So in this case we have the depth, current flow rate, current node me, current node elephant. Well, how do I represent this? Take you 4 minutes to teach an elephant how to open the right valves in the right order. We both start at AA. You move to valve JJ, the elephant opens valve DD. I guess I then have to adapt this to current node. For, I guess, yeah, for in range 2. It's a bit hard-coded, but hey. Yeah, let's start with the opening a valve. Current node is current node. Current nodes. That seems fair. Current node is current nodes I. If the current node not in open valves. So in this case, I guess we want it to be mutable. Yeah, we want to mute this because otherwise we start opening 2. Flow rate is higher. Time remaining is still that. The new flow rate is current flow rate plus flow rates times the open valve is the open valves plus current node. So what I don't like. So the issue I have is that I want both actions to be executed at the same time, so I can't append this to the frontier because I need to check what the elephant does as well. That's a bit weird. Oh man. So the options which could happen is like open a valve, and then I need to change more than one thing. Then open valves would not be the same. Or I could like open a valve, move to a different valve, move to a different valve. Yeah. Those are the 4 options we have. So how do you do that? I'm now just thinking about generating those kind of things written like a text and then just parsing the text. But that also kind of feels a bit lame, but it might be good enough for now. So I can do 2 things at the same time. Let me still think about this for a bit. Maybe I guess what I can do is actions human, because and then we can zip the things because we can do both of the things. I think that might actually be the best. So then for the actions for the human dot append so we have open a valve and then current node 0 because that's where we are. I guess we only need to do that node 0 not in open valves and flow rates of current node 0 / 0. Then we can open it. The current node 1 is larger than 0. Actions elephant. I'm very unhappy at the moment with how manual this basically is, but then again, it is fine for now because I'm still a bit confused, so I want to get a good feeling for what's going on, and it might help me a bit to explicitly see what's going on. So for neighbor and neighbors of current nodes, actions human move to there, and the elephant can move to his own neighbors. For action human in and action elephant in zip action human and action elephant. Oh no, that's not good. From iter tools import combinations. Actions 1, 2, 3. Is it combinations or not? Permutations, maybe? No. Use the iter tools of actions in two lists. Is it products? It is the equivalent of nested for loops. One 3, 1 4, 2 3, 3 4. Okay. I don't know why I pride myself that for the first 16 days I have not Googled a thing, but yeah. Did you know I pride myself that so far I have not Googled a thing? That's quite funny, I think. That's pretty cool. For action human in products of action human actions elephant. Okay. So then we've got, let's see. We got a new flow rate is equal to current flow rate. New open valves is equal to open valves. New current nodes is equal to the current nodes. Let me see. Time remaining is correct. The new flow rates. We add the flow rates. Yeah. And what we take for granted right now is that the elephant should not be able to open so then if action 1 not an open valves, okay, then we have that the frontier dot append the +1, the new flow rate, new location, new open valves. Otherwise we're moving, right? And then the new current nodes is the actually Newman current nodes 1. And then, of course, the elephant can also move. So I think we now cover all the combinations. We go to a new depth. We have a new flow rate, which gets updated. Elephant and human cannot open the same thing at the same time, or at least the flow rate does not get added. So that's good. Well, let's just maybe see and... Oh, we found again a better answer than this thing. Oh yeah, but of course, because we have the is 26. Oh, and I still have the previous thing. 1707, perfect. Two 66666. That's the right answer. You are 1 gold star closer to collecting enough star fruit. Alright, I must say that overall I'm definitely not too unhappy with how this went. The solution seems to be good. The code is not too ugly. Yeah, I think it's a pretty good day. Alright, yeah, well, hope you enjoyed watching. Sorry for being a bit late today, but as I said, I had a lot of work to do this morning and I was tired, so I figured I would rather do it later. And have a nice day.